Hello everyone. In our last session, we understood what we mean by function. I mean definition of function, terminology, and how do we represent a function. Now in that we have learned two terms, domain and range. And along with that, some simpler terms like value of the function. Let us take today some examples on domain and range of the functions. My first illustration is that a function f from R to R is given, and it is given in three parts: x less than 1, x between 1 and 3, and x greater or equal to 3. And we are expected to find values of the function at x equal to 0, x equal to 2, and x equal to 5. Now, when I find f0 there, I realize it stands for value of the function at x equal to 0. Means I am replacing x by 0. So I replace x by 0 and I get it is 3 into 0 square, which is 0. Now realize this, that from where I have found this value of the function, x equal to 0 lies in the region x less than 1. So first part of the definition I will be using, and there I have substituted x equal to 0 to get f0. Now next part is f2. That means I replace x by 2. Now where x equal to 2 lies? It lies between 1 and 3. So second part of the definition we use, which is x minus 3. So replace x by 2 and you get it is 2 minus 3, so it is minus 1. And then comes f5. That means I will have to replace x by 5. This x equal to 5 lies in the region x greater or equal to 3. So there I substitute in x cube, x equal to 5, and I get it as 125. Now this particular question was only taken so that you get clarity in value of the function, 1, and 2, that whenever I say that value of the function is different from name of the function, I mean you have to understand the difference. So I felt that this example would make that clarity to you. Now let us move to next. That is regarding domain and range of the function. Function is defined as x square minus 3. This is definition of the function. Now recall what we mean by domain. Domain was set of values of x on which function was applied, and the corresponding answer what we get, that was y, and it appeared in codomain. And all those values of y which lie in codomain, which became images of some values of x, that particular set of values of y was called range. So before I attempt the question, I thought once we revise what we mean by domain and what we mean by range. So basically, domain is values of x for which function is defined. Now, is there any value for which fx is not defined? Means x square minus 3 is not defined. X square minus 3 is defined everywhere. I mean, it is not like 1 upon x square minus 3. If that was the case, then I would have looked for values of x for which denominator becomes 0. I hope you are understanding what I am saying. So, fx equal to x square minus 3 is not at all troublesome anywhere. So, domain is simply all x belonging to R. At the same time, I observe that x square is greater or equal to 0. So, you are adding minus 3 to a non-negative quantity. So, obviously, answer for fx would be greater or equal to minus 3. Now, since function is well defined everywhere, so domain is R, but values of the function start from minus 3. I mean, minus 3 is included. So, corresponding range of the function, what I find would be nothing but minus 3 to infinity, minus 3 close. I hope you have got some idea that how we find domain and range. Now let us move to third question. It is, again we have to find domain and range of the function. And function is defined as 1 upon x square plus 1. As I said in previous question, that when quantity appears in the denominator, then that may be troublesome to us. But again here, x square plus 1 never becomes 0 for any real x. So realize this, that fx would be defined everywhere. So my first observation is, if I write that fx as y, it would be 1 upon x square plus 1, and y is defined for all x, and hence domain of the function is R, because there is no troublesome value of x for which y will not be defined. So domain is capital R, that is set of real values. Then I rewrite that y. look at that y. Y is given in 1 in terms of x. That means what we are given there is y in terms of x. And what I am expecting to write is that I will write x in terms of y. When I want to write x in terms of y, my simplification would be that I write first x square and I get it as 1 minus y upon y. Now, that leads to x equal to plus minus under root 1 minus y upon y. Now realize this, that x belongs to R. We want that square root of 1 minus y upon y to be a meaningful quantity for which 1 minus y upon y should be non-negative. Do you remember where we have seen this? We have seen this kind of expression in basic algebra where we had done those rational inequations. So 1 minus y upon y greater or equal to 0 is equivalent to y minus 1 upon y less or equal to 0. Recall critical points 0, 1. Then you will mark them on the number line. And then from there we try to find out for which this inequation is meaningful. And we realize that x should be between 0 and 1. There is no part before 0 which gives us meaningful value of x. And there is no part after 1 also which gives us meaningful value. So realize this, whenever y is between 0 and 1, then we get x meaningful. Also, inequation is of the form non-strict. So numerator's critical point participate in the solution set. Denominator's critical point do not. So realize this, that 0 will not participate but 1 will participate, and hence range is open end at 0 and closed end at 1. So semi-open interval you have here, and that is nothing but the range of the function. So now this question was little different from the previous one. In the previous one, we didn't have something in the denominator. So I had to speak little more here. So let us go to next. The next one is fx is defined as x upon absolute value of x minus 1. Now again, when we look at that absolute value of x, you have to devise your basic algebra part. Not only that, quantity absolute value of x minus 1 appears in the denominator. Now this may be a troublesome quantity because at x equal to 1, absolute value of x is 1. And also when x is minus 1, again absolute value of x is plus 1. So for these two values of x, I can observe that denominator absolute value of x minus 1 will become 0. And hence for these values, y will not remain defined. So x equal to plus 1 and minus 1 cannot be in the domain. So my domain should be r minus, and then I remove, when I write minus, set containing minus 1 and 1. So we are ready with the domain part now. Now let us go to range. Because of presence of absolute value of x term, we will have to take two cases. Now absolute value of x is minus x if x less than 0, and it is plus x if x is non-negative. This we have already done. So if I have to get rid of that absolute value notation, I will have to take two cases. My first case is when x is less than 0. Then obviously y becomes x upon minus times x plus 1. Now if I just multiply that x plus 1 on two sides, I get x into 1 plus y equal to minus y. Now what is my aim? My aim is to get x in terms of y, like the previous question. We are given y in terms of x. We are looking for x in terms of y. I try to write from here x in terms of y, and that would be minus times y upon 1 plus y. Now when I am writing here y upon 1 plus y, I realize that this would be meaningful only when y is not minus 1. So whenever y is minus 1, we will not be able to get any x. So y equal to minus 1. Where does y lie? Y lie in the range. So realize this, y equal to minus 1 cannot appear in the range. Now let us go to the second case, and I realize that my second case is going to be nothing but when x is greater than 0. Now that simply leads to y equal to x upon x plus 1. Now again, try to write x in terms of y from here, and I write it as y upon 1 minus y. Now when you are writing 1 minus y in the denominator, y cannot be equal to 1. So realize this, that y equal to minus 1 also cannot participate in the range. Same way y equal to 1 also cannot participate in the range. So the range would be r minus set containing minus 1 and 1. So we have found range also. All the questions this time I have not kept in the multiple option way, because what happens most of the time when you keep solving only multiple. At times you try to judge the question. At times you try to just by observation or maybe by guessing also, I would say, try to answer the question. So I thought these questions without options, let us try right from scratch till the end. Now, I think these 4 questions will give you some idea that how we find domain and range. Mind you, please, finding domain is always easy. Finding range is not restricted to only those methods what we did just now. There could be some more methods also, maybe in the following chapters I am saying. So finding range surely is not a simple task, but some rough idea you surely had in this session. Now, when I come next with another topic, you till then please solve these questions, keep revising. Thank you.